Welcome back to our next video on using Microsoft Excel for Pearson and Spearman correlations. Now, before we get too far into this, it's important for us to review Pearson and Spearman correlations. And one of the key factors that's often forgot about is that we often have to meet this normality assumption for Pearson correlation. So depending upon what you're testing, there are normal stats and non-parametric stats, and environmental data, income data, health data are often non-parametric. So we already know that. We can look at histograms to make that kind of determination. So when do we do a test for correlation? Well, you might be interested in seeing if X is related to Y. It could be something like the amount of a particular chemical in the water, and you have a bunch of water samples, and you also have county level data on stomach cancer frequency, and you want to see, are they correlated? Doesn't mean they're causal. Next, you might have a community that is dealing with high levels of particulate matter. We want to see if the number of cars passing on a highway is related to the amount of particulate matter in that air. Maybe you've got two different types of monitors for measuring manganese dust. One's expensive, one's easier and newer to use, and you want to prove that the newer, easier one works. So you might do a test for correlation. You could also maybe look at, are auto fatality rates related to the percent rural, because open roads in the rural environments, people can drive faster, and then when they wreck, the wrecks are more fatal. Maybe you got two different types of ways of measuring E. coli, a petri dish method and another method. You want to compare them. How might you do that? So you could compare them using a correlation test. Now it's important for us to remember that correlation is not causation. So we got our umbrellas. People are getting lots of umbrellas. Do all the umbrellas cause it to rain? Because there's a correlation between the number of umbrellas and rain. On days that it rains, people buy more umbrellas. And in this case, the rain is causal for actually that relationship, but it's not always causal, and you know that. Let's look at Major League Baseball salaries. They've been increasing since 1999, actually going back a lot further than that, pretty steadily. Also, autism rates. They were just 1 in 5,000 cases of autism in children back in 1975. In 2012, they say that there is 1 in 88 kids, and I don't know what the current numbers are, but on that autism spectral disorder, that's a lot. And a lot's changed really quickly. So if we were to plot Major League Baseball player salaries versus the autism rate per 1,000 people, you'd see that the highest paid baseball players are correlated to the autism rate. So there is a statistical correlation. If you were to do the p-value on that correlation, you'd see that it's a statistically significant correlation. We could also plot the autism rate against year as a continuous variable, and this is a continuous variable, and we would also see a statistically significant positive correlation. Doesn't mean that it's causal, but it's an important statistic, needless to say. So, testing for correlation. Correlation coefficients can range from -1 to +1. 0 means no correlation. And if the correlation coefficient does not cross 0, then that means that it's a statistically significant correlation. So, no p-value is typically given in Excel. There might be a harder way to get it, but not based off of the way we're going to deal with it today. So, here, if you had a p-value, a high p-value indicates we fail to reject the null hypothesis and have insufficient evidence to conclude that the correlation coefficients are different than 0. So if it can cross 0, then there is evidence that there's no correlation. So we'll show you that I'll show that on an image here in a second. For normally distributed data, when our histogram is bell curved, when we don't have skewness or kurtosis that's out of whack, we can use the Pearson correlation method. If the data are skewed or don't fit the bell curve, The non-parametric method is the Spearman correlation test, sometimes known as the Spearman Rank test or sometimes called the Spearman Rank order test. And we can force Excel to do that, and I'll show you that here in a minute. So again, correlation coefficients can range from -1 all the way up to 1. Sometimes people will refer to it as -100% to 100%, but that's probably not the best way to saying it. Pearson correlations are presented with this with this letter R. You can also get the R square by squaring it, and you'll see it presented like that. Often you'll see the R square in linear regression models. The Spearman correlation coefficients are called rho values, and there's the Greek letter rho, and it's R little s. That is a way, that is a way, and that is a way of doing the calling or writing out what a Spearman rho value is. These range from 0 all the way up to 1, and then there's another scale that goes the other way, 0 to -1, and it's just the inverse of this. So if you have a correlation coefficient of like 0.45, on most stat programs you can actually get the p-value and the confidence interval, or at least the p-value, for this correlation coefficient. So there's some error in that correlation coefficient, and if it crosses 0, this is no correlation. So if it crosses 0, then the whole thing is deemed not significantly different than nothing, no relationship. So we would assume no correlation. The larger the error bars, generally the smaller the sample, or the tighter the error bars, the larger the sample populations. In this example, it'd be a moderate correlation, but it would not be statistically significant. So we would pretty much not use it. When you get closer to 1, you can have a nearly perfect correlation. When you get to 0, it's negligible or no correlation or trivial at best. All of this that you see here can be replicated on this left side, or on this side of 0 over here. So you can have negative correlations as well. Perfect positive correlation looks like this. You don't hardly ever see that. Usually there's some noise in it. Negative correlation, perfectly like that. Here's a very strong correlation, R of 0.8. Typically you might see something that looks more like this. This is still a pretty noticeable correlation. That is nothing. If you were to draw a line of best fit through this, it would be a flat line. Here's a negative correlation, pretty strongly negative correlation, and a perfect negative correlation. Now, how are we going to use Microsoft Excel to do these? And you've already had a little experience doing this, so we can just type in equals Pearson and then highlight whichever columns that we want. To do the Spearman correlation requires a little bit more legwork. So you have to go to your column of interest and then type in a formula. So if you're interested in looking at the correlation between median household income and smoking, and you've determined that one of those two variables or both are not normally distributed, then you would want to use a Spearman rank order correlation, and you have to essentially create ranks from lowest to highest for both variables. And I'm going to show you how you can do that, and that's going to be where we finish the video as I show you how to do these in Microsoft Excel. So pulling up Microsoft Excel, we may be first interested in seeing whether or not our variables that we're interested in are actually correlated. And in this case, we're going to look at median household income, and we'll do percent smoking. So is there a relationship or correlation between median household income and percent smoking? Now, one of the things we can do with our data analysis tool is we can do a histogram on the median household income variable, which is, if I were to go over here, right here, there it is. And I also have to create a bin range, which I don't have listed here. So I have to create a bin. So we have to have those bins because for whatever reason, Microsoft Excel can't figure them out. So we'll just create some ranges from 30,000 to 50,000, 70,000, 90,000, 110,000. I'm going to create bends. I like to keep them equally spaced. And Excel doesn't operate very efficiently with statistics. So when I run this histogram, and there's my G, or my input range, my bend range is there, and then I've got the labels there. When I do this, sometimes it stalls out and I forgot to click something, and I have to sit here and wait for this thing to stall out before I can do it again. This may run quicker on other computers. RStudio and other programs will do this way faster than Microsoft Excel. And I can pause this video until this thing figures out what it's going to do. So it finally finished up, and then here are the table that it provided, but I want to look at the chart. So I'm going to repeat this endeavor right here, tools, data, analysis, histogram, and I wanted to also provide the chart because that's what I want to see. And it's going to take it probably some time to do, so I'm going to pause this while it does that. So when it finally finished, it pulled up this particular chart, which does not look like a bell curve to me. So we could probably pretty easily conclude this is not normal, and that using a Pearson correlation, although easier, is probably not the preferred method. It's much easier, or there's no difference between Pearson and Spearman and other programs, but in Excel, it's a lot easier to do a Pearson correlation. We're going to do the Pearson correlation between smoking and median household income by just typing in equals Pearson and then highlighting, if I could type here, then highlighting our column of interest, which is median household income, comma, and our percent smoking variable. GG and TT are separated by a comma. I hit enter and it runs the analysis, and there we go. That correlation is a negative correlation of negative 0.596. So fairly strong negative correlation, and we can look at it graphically here in a little bit. But that is not the best correlation approach to use. The best approach to use would be the actual Spearman rank order correlation. So I'm going to enter a column here, and I'm going to call it MHHI rank. You can call it whatever you want. And then I am going to sort this particular variable, median household income, from lowest to highest. I'm going to use the arrow instead. You can do it whichever way you want, but here's our wealthiest county in the United States, number 1. And then I'm going to type an equal sign, that column above it, plus 1. And then I'm going to copy this and I'm going to paste it. And you can, I'm just showing you, this is a quick, easy way to make this thing go. And I'm just copying and pasting this all the way down to the 3,100th and whatever county there are in this data set for all of the counties that have income available. So it is a formula that is essentially copying itself for me to be able to quickly do a rank. There may be an easier way to do this, but this is the way that I've always done it. And it'd be a lot easier just to type in equals Spearman and then it do it, just like another stat program would do. But Excel, it's not hardwired to do this, so this is the way you have to do it. So I know I'm getting close to the end. So there are the counties with income. And I'm going to paste and shoot. Look what it did. So it didn't work. So I have to repeat this endeavor. If I would have just copied this all the way down, there we go, I tricked it. Copied that, repeated it, now it knows what I was trying to do. And there we go. So I got all of them ranked. Now I can copy this column, and now I'm going to paste special. and I'm going to paste the values. So that locks them. So it didn't change, but now it's hardwired these values. These values are no longer a formula. So that's a neat little trick. If you ever have a problem with Excel, just paste special, and then when you paste the column that you had highlighted special, select values. We have to now do the same thing with percent smoking. So I'm going to enter a column to the right of it here, and I got to highlight it. Now I might be able, if I like these columns, I've already got the ranks created, I can copy this for now and just hold on to it and see if it works. If I paste the values there, you know, be there. But I'm going to copy this first, copy it. I can't have the rows separated when I do my sort. I'm going to sort this. Oh. We'll go from lowest to highest. And then I'm going to insert a column. If I try to paste it, nope, I can't paste. And these are now out of rank. So I'll have to manually do this again. So we're going to do smoke rank. So this one will equal, granted these are ties, so the Spearman rank order correlation usually handles these ties better. For us, we're just going to rank them from lowest to highest to get to the point. But what you would ordinarily do is call this 1, and then all of these would actually be 1, 1, and then these would all be tied for like 4, 4, 4. You know, the ranks are tied. Here, for our purposes, we'll just do 1, and this equals 1 plus the number above it. And then we copy and paste this all. I know this seems really tedious, and it is. So some folks may only have access to Microsoft Excel with their employer. If that's the case and you have to do a lot of statistical analysis, just tell them you want to use RStudio. It's free. You'll be able to use RStudio free of charge after you've learned how to do it from this class. And it's just a lot easier to use. Any stat program is easier to use than Microsoft Excel. If you're just getting averages or something, or medians, you know, maybe Excel's just fine for that. But this is just awful. But you're learning how to do it the manual way. They call this brute force, is the name of this approach of having to do it. So we got smoking data for all of them, so I'm going to paste it. And here it doesn't like this, so I don't know what happened there. I hit enter on that one and it corrected them all. Now what do? I'm going to copy this and I'm going to paste special right over top of it, values. So it's locked them in. And now I can do my correlation again, but this time we're doing the Pearson is being done using the ranks. So we're going to do the Pearson of that rank, comma, the Pearson correlation on the smoking rank. Hit enter, and there is the correlation. And I guess I did my ranks backwards. So these are the counties that actually smoke the least, and these are in order of the counties of the richest. So you would expect there to be a positive correlation. If you were to flip the ranks around, you get an opposite. It'd probably be negative 0.69. So you'd actually have a stronger correlation using the Spearman rank order approach. So that concludes this particular video on using the rank order correlations. The next video we're going to do is going to be using linear regression analysis, and we'll also do a scatter plot, and that will for now probably, well, we'll do just a little bit on data visualization beyond the scatter plot, and we'll stop here.